So what do you do when you get tired of making double the horsepower of most Jeep engines out there? You design your own EFI turbo kit, of course. We're going to try to break some records. This is our third go-round with Newcomer Racing on the Horsepower Monster because they just keep doing ridiculous things with their 4-liter straight six Jeep program. In stock form, the Jeep and AMC straight six, which was installed in hundreds of thousands of Jeeps by both AMC and Chrysler for decades, was rated at 190 horsepower. First up, we did a low buck stroker build that upped the output to 304 horsepower on the cheap. Then, we came back around when Newcomer told us he was developing a system to adapt modern port fuel injection with a Holley ECU for better engine control. And that combo significantly upped the ante with 395 horsepower while still burning pump gas. That's more than twice the stock output. If you want to see those builds, I'll leave links to those videos in the description below. So now engine builder Keith Newcomer is back with a no-holds-barred turbo combo with the express purpose of making more power with the 4.0 Jeep block than anyone has ever before. For years, the given record for the Jeep Straight Six is an impressive 692 horsepower and 777 foot-pounds of torque, which was recorded by Four Wheeler Magazine in an article called Insane Inline 2. Since then, no one has claimed to even come close to that. Needless to say, Newcomer felt it was time to reset the bar, and he gave us a call. And when he told us he was either going to set a new record or blow the thing up, we knew we were in. For the foundation, Newcomer chose a 328 block casting out of a WJ, which is a Grand Cherokee. There isn't a huge difference when it comes to the 4.0 blocks, but the 328 castings usually have a slightly thicker cylinder wall, and they're also an NVH block with thicker webbing in the bottom. This engine is totally an R&D project for Newcomer Racing, so it won't be going into a customer's car after we're done. Still, the point here is if you can make this power with a 328 block, you can do it with practically any of the other blocks. Anyhow, all 4.0 blocks, including the 328, have a 3.88-inch bore, a 3.44-inch stroke, and a 9-inch 450 thousandths inch deck height. Newcomer has already had the bores punched out to an even 4 inches. Combined with a 3.895-inch stroke gained from using a crank out of the older 4.2-liter engine, that comes out to 293 cubic inches. If you're familiar with Jeep engines at all, hearing that Newcomer is running a 4-inch bore probably set off warning bells inside your head. That's double the conventionally accepted 60 thousandths maximum safe overbore for these engines. But he's already poured hard block into the water jackets to stiffen the block throughout. Here, you can see through the hole where the water pump bolts up, where the hard block comes to within a couple inches of the deck of the block. That gap allows coolant to still flow near the top of the bore and into the cylinder heads, where the greatest heat for combustion is localized. The hard block will significantly strengthen the block and prevent warpage of the cylinder bores. As I'm sure you know, an engine build is a multi-day process, so I left and worked on other projects while Newcomer finished installing the King main bearings, finished the pre-fitting process, and painted the block. I came back around when he was ready for final assembly. The Crankshaft is an OEM unit out of an older 4.2-liter straight six. This bumps the stroke up from 3.44 inches to 3.89. This is also one of the fully counterweighted cranks from 1980 and earlier Jeeps. Here's one of the lighter weight 81 and newer cranks for comparison. The older fully counterweighted crank is quite a bit heavier, something like 65 pounds to just 37 for the lighter crank, but it's also stronger, so that's our choice for this big power build. Newcomer prefers these heavier cranks for any builds over 450 horsepower or on applications that sees a lot of shock. Another issue with using the older crank is it has a longer snout. To get it to fully work with the newer serpentine pulley system, you either have to use a spacer to fully hold the damper against the timing gear, or you can modify the crank snout.
Yeah, so you don't have to do it. You can either run a spacer on the end of the crank, or you can cut the crank. I would rather cut the crank. Basically, Just use the silicone. All you have to do is, there's a mark. If you come over here and look at this one, roughly a 1/2 inch, you can see the parting line. If you cut around that, cut it off, then you don't have to run a spacer on the outside of the damper to push the damper all the way in. Because if you would put the damper on this without cutting it, you'd be a 1/2 inch short. So if you just cut the end of it off, it could even be further if you wanted to, as long as it has enough room to push it up to where it butts up against the lower timing gear.
After lubricating the bearings, Newcomer drops the main caps in place. We're keeping the OEM 2-bolt main caps, but they're going on 1/2 inch main studs from ARP. Instead of running a nut directly over the main caps, he installs these spacers that are approximately 1/2 inch thick. On top of that goes the steel main girdle that comes with all the newer NVH blocks. The spacers are necessary to provide space for the stroker crank and connecting rods so that they'll clear the girdle. This is a stock main bolt. Normally, the girdle fits over and is clamped down by the 3/8 inch mini studs that are on the end of the 1/2 inch bolts. To make it work with the ARP main studs, the holes in the girdles just have to be drilled out to a 1/2 inch. Once that's all in place, a washer and nut can be added to the studs and torqued down to 100 foot-pounds. The camshaft is a solid flat tappet from Bullet Racing Cams. Now I know what you're thinking. If this is a no-holds-barred engine, then why not a solid roller setup? Well, the truth here is that there's just no good roller cam and lifter option out there for a Jeep Straight 6. This engine platform just doesn't have the same support in the aftermarket as many V8s. Anyhow, this cam is ground square with 243 degrees of duration for both the intakes and exhausts at 50 thousandths tappet lift. The intake lobe centerline is at 108 degrees and the lobe lift is 365 thousandths of an inch. With the 1.6:1 ratio Scorpion rocker arms we'll be using, gross valve lift will be 584 thousandths. A billet timing chain setup connects the crankshaft to the bullet cam. Newcomer didn't think the stock rods would hold up to the power levels needed to break the world record. There aren't a lot of options out there for hypo Jeep connecting rods, but Scat does make the forged rods which we'll be using. Scat calls these I-beams their Pro Stock connecting rods. They're 6 inches 125 thousandths long, and Newcomer has already upgraded them with a bushed little end to accept a floating piston wrist pin, as well as stronger ARP 2000 rod bolts. They've also been outfitted with a set of King rod bearings on the big end. Those connecting rods are fitted up to a set of custom pistons from JE. These forgings have a 4-inch diameter with a 1-inch 355 thousandths compression distance and a weight of 487 grams per piston. A 28cc dish helps keep compression in the turbo-friendly zone of 8.6:1. A set of wire locks secures a 866 thousandths diameter wrist pin in the piston, and the piston to cylinder wall seal is maintained with a set of 043 rings. Because of the heat that will be created by combustion under pressure from the turbo, the ring gaps have been opened up to 36 thousandths of an inch, which is bigger than the 22 to 24 that Newcomer usually runs with his naturally aspirated builds. Once the pistons and rods are in the cylinder bores, the rod bolts are tightened to 45 foot-pounds. Up top, Newcomer is using a set of solid flat tappet lifters from Bullet to go with the Bullet cam. Besides using a quality motor oil to help keep from wiping a cam lobe, these lifters have a tiny oil gallery cut from the body to the lifter's face. This injects a steady stream of pressurized oil between the lifter tappet and the lobe of the cam. The lifter bores are deep in the block, so Newcomer uses a magnet to get each where it belongs. And for those of you about to type, "Never touch any engine part with a magnet," in all caps in the comments, take a second and take a deep breath. This is industry standard practice and just about the only way to get the lifters in the bores because they're so deep in the block. Newcomer degrees in the cam to make sure the valve timing will be on point. Now on to the cylinder head. Edelbrock makes an excellent aluminum cylinder head for this engine, and Newcomer even used it in his high power EFI build that we covered recently. But for this record-breaking attempt, he wanted to keep an OEM head along with the block and crank. So he spent many hours fully porting this cast iron original head by hand, specifically for making turbocharged power. Boosted engines usually like a combustion chamber that's fairly open. They don't depend on swirl and tumble or even quench like a naturally aspirated engine does. Since the turbo makes its own compression, it seems to do best with a clear open area for a nice fast flame front to travel across the combustion chamber. So Newcomer built a turbo-friendly chamber by laying back the cylinder walls and removing material from around the spark plug. All that work opens up the stock chambers. Depending on the model year, the stock chambers can vary from around 55 to 58 cc's. But once Newcomer got done, the chambers are quite a bit bigger at 66 cc's. And just to help you visualize the difference, here's a stock chamber for comparison. Combined with the dish of the pistons, there's plenty of open area around the spark plugs for clean ignition and a nice fast traveling flame front. Both the intake and exhaust ports have been opened up. For these, Newcomer concentrates on raising the roofs and cleaning up the short turns so there isn't the typical bottleneck limiting flow around the valve guide boss that you normally see. The bowl area and seats have also been enlarged to accept a set of 2-inch 55 thousandths intake valves and 1-inch 650 thousandths exhausts, both with narrow 8mm stems. Compare that to the 1-inch 910 thousandths and 1-inch 500 thousandths stock valve sizes, and you get the idea of the changes we're talking about. About the only thing that stayed the same on these heads is the 45-degree valve seat. For the valve springs, he's chosen a set of Comp Cam's 26 918 beehives. These LS-style valve springs have a pretty standard 1-inch 310 thousandths outside diameter at the bottom of the spring, but at the top it narrows down to just 1-inch 75 thousandths. That not only cuts the overall mass of the spring, especially at the top where it sees the most movement, but that means it also uses a smaller retainer, which helps reduce the valve train mass. So, for a lighter spring pressure, you can get better high RPM valve control. On the seat, these springs have about 145 pounds of pressure, and the spring rate is 372 pounds per inch. By the way, I forgot to mention that this cylinder head is from a 91 model engine and is a high output head. It goes onto the block with a Cometic multi-layer steel head gasket with 49 thousandths compressed thickness. The valve cover may look fancy, but it's really just a 91 through 95 casting that Newcomer's machine smoothed and polished. The welded on fittings are there to fit the stock breathers. Here's another look at the hard block, which you can see where the water pump normally goes. A stock water pump won't work anymore because the pump extends into the block's water jacket. So Newcomer has gutted a regular pump housing, and now it's really only an inlet. To move water through the block and cylinder head, he'll use an external electric water pump. No big deal. Oh, and we have another stock, or at least modified stock component. The oil pan is an OEM stamping, but Newcomer had to extend the floor of the pan to make room for the stroker and reduce windage just a bit. And now we jump forward to the dyno. We've skipped a few component install steps, so I'll try to catch you up. This engine is using full electronic fuel injection and Holley Dominator engine controls, just like Newcomer ran on his 395 horsepower EFI build. This includes a custom crank trigger, a one-of-a-kind cam sensor, a Holley Dominator ECU, and individual coil packs. This whole setup is really cool, and if you ask me, very interesting. but I just don't have time to cover it all in here in depth. I definitely recommend that if you haven't already seen it, you check out the video on the EFI build. And like I've mentioned, there's a link to that video in the description below. If you watch that EFI Jeep build video, you'll also recognize Newcomer's custom-built cannon intake with its huge plenum. This is the real reason that intake was built. It's outfitted with an eBay 92mm throttle body and 80-pound injectors. The stainless steel exhaust manifold is also custom fabbed by Newcomer Racing. It's built to work with the turbo setup, but first we wanted to get a naturally aspirated baseline. We're at Automotive Specialists using their dyno, and Jeff Dorton is handling the tuning duties. After just a few partial pulls, he had the Holley engine management system dialed in, and we were ready to make a naturally aspirated run to see just how much power this low compression motor would make without a turbo. Even at 8.6 to 1 compression, this is a very impressive engine. Newcomer spun it all the way up to 6,400 RPM with no real sign of loss of valve control. It made 343.5 foot-pounds of torque at 5,100 RPM and 351 horsepower at 6,000. But what's also very interesting to me is the flat torque curve. In the video of the EFI build, which again I really recommend you watch, I explained away a dip in the power from 52 to 5,700 RPM as possibly valve spring harmonics. Newcomer, however, felt it was an issue with the stock harmonic damper. So for this build, he fabricated a custom hub to mount an SFI-specific ATI damper for a big block Chevy to the Jeep. He also switched to beehive valve springs, which are much less susceptible to harmonics. Either way, the dip is definitely history. So with the engine running strong and Dorton confident in the tune, we began adding the turbo components. First up, you guessed it, the turbo. This is a 76-75mm unit from On3 Performance with a CNC billet compressor wheel. On3 says it can support up to 1,125 horsepower, so it should be plenty for our needs. For an intercooler, Newcomer simply sourced an eBay air-to-water unit and modified it to his needs. Both the air inlet and outlet are 3.5 inches in diameter and mount up with V-band clamps to ensure that the tubing won't blow off when the boost creeps up. By the way, the intercooler mounts and the way everything is arranged is simply to make fitting everything up on the dyno quicker and easier. It isn't designed to fit in any particular vehicle. All the aluminum intake tubing he's using here is also 3.5 inches in diameter. Both the wastegate and blow-off valve are also from On3 Performance. The blow-off valve is sized at 50mm while the wastegate is 60. There are also provisions for water meth injection, but Newcomer wanted to start off with just boost, so we'll get to that in a minute. What's surprising is how quickly Newcomer and Dorton were able to go from an optimized, naturally aspirated setup to boosted without missing a step. The Holley ECU is a self-learning system, and Dorton was able to reconfigure it to work with the turbocharger in just a few minutes. This includes tracking and managing boost, a new boost reference fuel map, and a timing curve that automatically retards depending on boost levels. And just like that, we were back at it. After just a handful of pulls, Dorton had the timing dialed in, and we were comfortable running the boost up to 20 pounds. Obviously, you've noticed that big cloud that erupts from the engine at the end of the pull. I'll be honest, the first time this happened in the dyno cell, I thought it had blown an intake gasket. But as I slow it down, you can see that it's actually coming from the blow-off valve. Newcomer says he can fix it pretty quickly, but since this is an R&D engine and it won't be going into a vehicle anyway, we just continued to let it rip. First off, you'll notice we stopped the pull short compared to the naturally aspirated run. 750 horsepower was the target for this go-round, so when we got there, we stopped. Still, that was enough to more than break the previous record. On boost and water method injection, the previous record was 692 horsepower and 777 foot-pounds of torque. Newcomer blew right past that mark and came up with 750.9 horsepower at 5,500 RPM and matched the torque figure with 776.7 foot-pounds of torque at 4,600 RPM. But Newcomer knew this engine had more in it. To up the safety factor a bit as he continued pushing the limits of this engine, he hooked up the Snow Performance water methanol injection. We're using a number 6 injector, and the system is set up to come on when it sees 12 pounds of boost and ramp up until it's full go at 17 pounds of boost. Newcomer is using Snow's own Boost Juice, which is 49% methanol and 51% water, but we know a lot of people who simply use windshield wiper fluid from the local box store. The point of water method injection is to inject an atomized spray of water and methanol into the intake charge that both cools the air going into the engine and ups the octane rating of the fuel once it's added, which makes the engine more resistant to detonation. So let's go. After a little testing, we wound up going to 21 pounds of boost with a little less ignition timing. This was my first time messing with water methanol injection, so I really didn't know what to expect. Boy, was I surprised. Peak torque jumped 105 foot-pounds to 881.7 at 4,800 RPM. And we also saw an increase of 110.4 horsepower to 861.3 at 5,700 RPM. Again, horsepower was still climbing quite quickly at 5,700. The only thing that stopped it was Newcomer pulling back on the handle. Newcomer Racing not only beat the old record of 692 horsepower and 777 foot-pounds of torque, they demolished it. They've set a new standard for making power with the Jeep Straight 6, and best of all, done it while still using the OEM cylinder head. So, where's the limit for this engine? Really, we still don't know. Newcomer doesn't feel that this turbo package has come anywhere close to maximum power. He wanted to be able to take it back to his shop in one piece and smoke it over to see just how the internals were holding up. And the answer is it did surprisingly well, thanks to intelligent component choices and modern engine controls that ensures the air-fuel mixture always stays on target. Maybe someday he'll take it back to the dyno and make a run for an even grand, go or blow. And you bet we'll be there to record it for you if he does. Hey, thanks for watching.